So divide square root of 20 divided by 6. So this will be on the test. It will not be on the quiz today. Okay. No, the quiz today goes through what you learned last week and what was on the box. So what I need to do to be able to do anything to this is simplify that square root of 20. This should be a piece of cake for you by now. So the square root of 20, do our factor ladder. You go ahead and do it while I do it up here. So it looks like the square root of 20 should be 2 square root of 5. You guys good with that? So let's replace the square root of 20 with 2 square root of 5. It's over 6. So now we'll look at like the whole number part and the square root part to see if we can simplify any more. So this is the fraction 2 over 6. Can that be simplified? It can be reduced, right? Both of these divisible by 2. So that's going to be 1/3. Be careful. Sometimes I have students wanting to divide that and make it a 3. But when the smaller number's up in the numerator, the smaller number has to stay in the numerator. So this is going to be 1/3 square root of 5. Or it can be written like this. The 1/3 just in front of the square root of 5. So something like this one. So what I look at is that numerator, no matter what happens, I'm not going to get to combine those numbers because we're not going to have the same square root. So this is going to get split. And I'm just going to split it right now so you see what we're doing. That 16 has to be divided into both the terms up there in the numerator. So split it into 2. Then it's like 2 little separate problems like we just did up above. Okay? We can simplify the 4/16. What does that become? 1/4. They're both divisible by 4. Now, the next piece we're going to need to do a little bit of work with, right? So let's do that off on the side. So let's see, are we divisible by 2? Okay. And then 2 again. And then 2 again. Scott. Okay, thanks. Okay. So without even writing it out, let's see, that's going to be 2 comes from here. I'll write it. So 1, 2. So that's 2 times 2 square root of 2. So it's 4 square root of 2. Notice how I'm kind of doing this work off on the side. It's like my scratch work. And then I'm going to bring it back in. So in place of the 32, I'm going to put 4 square root of 2 over 16. Now, that 4 over 16, can that be simplified? Yeah, that would simplify to what? To 1/4 also. Okay. So it's 1/4 plus 1/4 square root of 2, or since those now both have the same denominator, we can write this over one denominator. We can write it as 1 over 1 plus the square root of 2 over 4. That's how the answer's written in our program. I think they should take it like this also, but we may have to double check that when we get there. Yeah. It should, but it may want us to put them together. We'll have to play with it. Okay. Okay, any questions there?
I just need a little more time to thought this down.
Okay, that's fine. Okay, let's see. How about something like this? The square root of 200 over the square root of 72. So what do you think? What do you think we're going to have to do here? Okay, so I'm going to actually go through and simplify both of these separately, like they're separate problems. Put the solutions to those back in, and then see if we can reduce anything. So I'm going to do 200, and I'm going to do 72. So let's just go through it. Go ahead and do your factor ladder on your own. You shouldn't be just copying. You guys know how to do a factor ladder. Okay, so 200, let's circle our pairs. There's a 2 and there's a 5 pair. So that's going to be 2 times 5 square root of 2, which is 10. And then on the 72, there's a pair of 2s and a pair of 3s. So that's going to be 2 times 3 square root of 2, which is 6 square root of 2. Okay, can I simplify 10 over 6? Yeah, they're both divisible by 2. So that's going to become 5 over 3. And what happens with this square root of 2 over square root of 2? Same thing in numerator and denominator can cancel out. So there your answer is just 5/3. Any questions there? Let's go. I'm going to do one more example. Oh, back up. Sorry. I know you guys like to listen and then copy, so that's good. Okay. So one more example here. Let's do... try this one, see what happens. 135 x to the 10th y over 6x to the 4th. This is going to be the square root of 6x to the 4th y to the 5th. Okay. So I need to look at that 135 and see if I can break that down, right? Is it divisible by 2? Is it divisible by 3? Yep. It'll be 45. Now is 45 divisible by 3? Yes. And is 15 divisible by 3? Okay. So when I simplify this, I have a pair of 3's, right? So it's going to be 3 square root of 3 times 5, which is 15. Now, can you simplify the 6 at all?
Yeah.
2 and 3, but there's no pairs, right? So I can't really simplify that square root part of it. Okay, so let's look and see what we have, and then look and see what we can do with it. So right now I have 3 square root of 15 x to the 10th y over the square root of 6 x to the 4th y to the 5th. Okay, so I have taken care of the number part. I haven't taken care of doing the square roots of the variables, if I can. So can I do the square root of x to the 10th?
Yes.
X to the 10th would come out as x to the 5th. Now can I do anything with the square root of y? No, it's going to just stay, right? So now we're going to have 15y. Okay, what about the square root in the denominator? I know the 6 has to stay. So the x to the 4th, it's going to come out as x squared. What about y to the 5th? Okay, remember, we have to think of that as y to the 4th times y, or y to the 1st. So a y squared comes out. I'm just going to write it in front. And a y stays underneath. This one's a bit challenging, huh? Lots of steps here. Okay. So now I kind of just need to ask myself again, is there anything I can simplify? Well, so let's look at the stuff outside of the square root. We have an x to the 5th over x squared. What do you do when you're dividing with exponents? Subtract them. So this is going to be 5 to the 5th over x squared would be x to the 5 minus 2, or x to the 3rd. So, like, if you want to think, like, if you didn't remember that, you could do 5 x's, 1, 2, 3, 4, 5, and 2 x's on the bottom, in the denominator, and then cancel out the pairs, and then what's left is your x to the 3rd. Okay, so if you forget whether you add, subtract, or whatever. Okay, now, this part. So the stuff that's under the square root, we can now consider it all as one square root. And do 15 over 6, y over y. So now what cancels? The y's will cancel. They're both under the square root. Now, can that 15 over 6 be simplified? Yeah, they're divisible by 3. So what is that going to be? 5 over 2? Oh, yikes. Okay. I thought that one was going to be a little frightening. Yeah. And technically we have one more step that I'm going to hold off until tomorrow. Because the other thing with square roots is that you're not allowed to leave a square root in the denominator. Yeah. Yeah, actually, let me check. I think I can take the problems out that have that, and we can wait and do that type of work in Algebra 2. Yeah, because in Algebra 2 I teach that as a whole new lesson, like you've never learned it before.
Yeah.
So,
I like that idea.
yeah. Really, what you do if you're just curious to get it out of the denominator is you multiply both by the square root of 2, whatever that square root is that's in the denominator, and then it kind of just takes care of it. It's not that difficult, but it is just another step. Okay. So we are done with that.